Okay, we'll go ahead and get started. We're going to have some breakout discussions. So on the back of your card is a number, just so you will orient you around that. It's number 1 through 4. If you are, what do we decide for the numbers? Is who's staying in here?
So
you staying?
I'm number 4.
Number 4 is going to stay in here, and number 2 in the back. So if you're number 3, that's with me. We're going to be around the corner and down the hall here. And
number 1 is going to be in a conference room over there.
Yeah, so it's on the back of your name card. So about 2.5 years ago, we ran a workshop like this one. So some of you were there. I recognize some of the faces from that. And we talked about what was happening in crystal growing efforts on station and what the future would hopefully look like. What are some of the things we should work on? And I've got the output from that in my pocket, the notes from that. And I think we've over the past 2.5 years actually addressed some of these points, but there's still things that need to be done. Yeah, I'll go through it at the end. So I'm going to go through this and I'll tell you where to go when I'm done. So, but for the things the topics that keep on coming up and are still coming up, we've listed here, and we want these to be kind of the foundation for your discussion. There'll be other questions that we're going to pose during the breakouts, but we want you to think about these 4 topics. So information sharing is really about both execution. How do you do it? How do we tell new users how to do it? How do we get the word out that this is an option and that's a viable one? And also, how do we share results, both positive results, whether it be through mainstream journals or presentations, what have you, and the negative results. What doesn't work, and how does that inform us and what we're going to do next? So capabilities. Capabilities is a mix of things, but it's really about what hardware or a technology on station needs to be there to enable crystal growing efforts on station and make it something that will live on into the future. So what are the things that, let's say, technology that you have on the ground now in your lab or you have access to that would make things work better for you on station? Molecule of interest. So what are the targets? What are the molecules that we want to go after? Or maybe even understanding trends in what works and what's viable to go after. And I think there's also a piece of that, and it may be a group that's missing from this, but what are the targets that are meaningful to the general scientific community that we should be considering and making an effort to go after? Whether that's specifically pharmaceuticals or other types of molecules, pharmaceutical directed, or molecules that are related to materials or other things. And then imaging and analysis. So this is a more pointed question around capabilities on station, but it's how do you understand what you're doing on station, and then how do you get meaningful information from that on station and then after? Right? So what are you going to do so your samples are enabled to get the most information out of them? Are there questions around any of these? Is there anything that I missed? Or
I think other than to say, I think that we have a bunch of questions, but I think we're just looking for you guys to pose questions as well as
yeah. This is our chance to really get feedback from you and to start on the cases to start to formulate a plan of action into the future. We have proposals for new capabilities or new targets brought to us often, and we want to hear from you, the experts, as to what we should be doing, what should we be considering, or what would make a real difference. And with the understanding, as Mark pointed out when he discussed the RFP, that our ultimate goal is to turn this into a sort of a viable commercial effort. So what will we need to do so that in a couple of years, people are coming to us and they're paying for the service? Okay? And that may require a significant investment now that we have to consider with our colleagues at NASA, and we figure that out, but we need to know what that has to be. Okay, so again, the numbers are on your tags on the back. If you're in group 3, you're with me, and we're going to go out and around and down the hall. There's a room down there. If you're in group 1, you're going to be in a conference hall. It's sort of across the this little open area on the other side. And then if you're in group number 2 or group with Molly, or group number 4 with April, you're going to stay here. And we just wanted to break it up so we could have open conversations and not be too disjointed by the other groups. When we're all done, we are going to come back and we're going to read out what were some of the things that came up, and there'll be a chance for discussion with the larger group, and then we'll end it and have a networking session. Okay.
So meet back at 3:10.
Yeah. So it gives about 40 minutes to do it, to get over there. Okay.
So this is for breakout group 1. So they're all occupied, so they can't comment if I miss anything. But as far as molecules of interest, the field with cryo-EM is probably going to take over doing the larger complexes. So that may be not to diminish that that's still a role for microgravity, because the group thought that there's still always going to be a combination of techniques, including X-ray, NMR, and cryo-EM. But that's probably one of the areas that cryo-EM will take over. There's still a need for small uniform crystals, not just the large ones for XFL, and for also potentially for monoclonal formulations or other drug formulations. It's tough to start from scratch with new molecules that you don't have any idea of the crystallization conditions, so it's definitely something that could be avoided unless you have long lead times. Monoclonal antibodies might be an area that continue to explore as more and more of the crystallization conditions start to become known. Microgravity may be able to push those over the barrier. So as far as information sharing goes, continue to go on the road and show the capabilities, allow people to touch the hardware, see what it's like, kind of dispel the mystery of doing science in space. But there's still the concern that is there going to be really a huge buy-in until there's some sort of, wow, this is what happened because of microgravity. As far as hardware capabilities, microscopes continue to be something that would be useful, probably on a basic research and kind of case-by-case specific. And then a question of, is there a way to transfer what you know with your vapor diffusion methods that's standard in labs today, and transferring what's known about that straight away into flight hardware or into some, we talked about the counter diffusion methods that Joe Ng uses. Can we just readily translate what everybody does in their lab to a flight hardware? That would be useful. Talked about can we publish what's going to pass NASA safety talks? So is that the GRAS 1 through 8 safety panel? Is there other known precipitates that we know will pass? Can we just publish that so people know? So when they're considering working in space, if there's any issues with what they're working with. And then we discussed what, at least from the academic side, what people might be willing to offset IP costs, and it comes to a value closer in the thousands, in the low end of the thousands. So one of the thoughts was that from the IP community side, is maybe cases could work with the IP community to help them drive business to them so that they can then maybe package 10 or 11 investigators together. So even though their per flight cost is low, maybe they're able to do it because they have multiple users on a single mission. I'll leave it at that, unless I'm missing something from group 1 that anybody wants to chime in on. Group 2.
Small molecules and molecules that can't be crystallized in aqueous solutions. So we want to lines. But again, we kept going back to maybe putting in projects and these small molecules that people are really interested in. And definitely said, I'm sure to buy everything in this slide. That trip was going to lab, so there's a lot of numbers on the slide. So let's see. In terms of information from this, so I guess the bio Excel, because we did a lot of papers, but also the big discussion that everyone was where can we get the information out there? And the consensus was going out and actually having this conversation with scientists and scientists that presenting at conferences and not just at science conferences. Anything that makes sense? Yeah.
There was in representing three. So one of the things we talked about was setting up a plan, some type of system that would be routine when their samples came back. They would have to try to figure it out, or they would all go through the same process, get processed the same way, sent to the same view, and get run there as an option. Take some of the load off the experimentalist and trying to figure out how to do the samples and run it. People were happy with the fact that somebody talking from the shuttle days, probably might guess who it might be, but that things become much more routine. It still takes time to get things done, but launch is very routine, and it's changing the way people are thinking of this as science, being able to do that. So there was a big discussion around the actual devices, the plates or what have you that you're going to run the crystallization in. And there's a lot of options out there, but it seems as though they're still all under development after how many years, still being developed. And there's not like a set of 5 examples that are proven and you go through the team and use those. And at one point we talked about what size and that 4 microliter drops aren't worth anything to some people. Like if you bigger batches and then what is the system that's available for them. And then even if there are some opportunities for you with available hardware, how do you figure out what those are? And who's done them and how those are used? And then the last part about that was, is there an easy way to set up a system where you can just adapt your own hardware and make it flight ready? And then is that being an option? But there still is a need to understand what is available and to have some type of logic tool that allows you to go through and say that these are all my parameters, what are the options, and how should I do it based on what you've done before. Imaging is important on station. Feedback is significant to be able to make any types of changes, otherwise it's just a black box, you're putting it up there, you're running it for a fixed period of time, it's going to go, and you get what you get without understanding what actually happened, or being able to fix it or make it better or improve upon it. Even if anything happened and it just got even somehow on the way there. If you can predict what works, that would help. So we were talking about picking targets and how that might influence the targets that you select to run. But the reality is, as we pointed out to us, there's a lot of targets that would say that that's impossible, and then all of a sudden somebody does it. And the people who should have the final say on what gets done is not basis or NASA, it's probably the experimentalist. And then it comes down to money, who's for it, and who's picking on this. Did I miss anything from group 3?
All right, so we kind of down this list that we had questions. So molecules are the molecules we should be focusing on. They say translational targets are important, but they feel like that might limit other research. So we should do both, and maybe the category of proteins instead of individual targets, like what Joe was talking about, picking ones that might be the best, maybe have that as part of a multi-category approach. Then we talked about if you can't crystallize a protein on Earth, should you bother applying it? And they agreed, no, if you have never had a protein, but if there is one that you do have microcrystals that you're getting, you want to include, then perhaps that would be worth flying, especially if it's molecules in Information sharing. What more can we do that good feedback that like this meeting is good to have, keep that going. It's good for information sharing. We also had a suggestion for new users. Could we have a new user portal, something like our IP portal, where new users could go in and see a list of frequently asked questions, like when can I expect the rocket to launch? How long should this take? When do I have to turn it over? The basics that we all think everybody knows, but nobody knows. And then also a way to ask questions, because the capabilities change all the time. So we have every 6 months, it seems like there's another capability that people are adding that maybe the other people in the community don't know. So is there a way that implementation partners perhaps could advertise new capabilities on this site, and a user could go in and ask questions? Hey, you might have done this with a plant, but hey, could I put a capillary in there instead of plant and do a PCG project? So just more information sharing that way. Hardware capabilities are one of the things that we talked about a lot is the recovery process is really insufficient right now. That we know it from Shuttle has a really good defined way of getting samples, and we had driving as a backup plan, and now we have you're on your own, good luck, and off you go. And is there a way to improve that? Is there a way to similar kind of to the corporate segment that we have kind of organizing beam time with them? Is there something to do that similar actually being kind of Argonne, that maybe you can even ship the samples from Long Beach straight to Argonne and have a coordinated process that way? But just the hand carrying on planes, I think everybody touched on the picture of driving the parking lot with a bag. If we do it seems like after it launches and comes back, we all just go, and then that's it. And that part is really lacking. Talked about more cold storage capabilities. We have a lot of capabilities, same with Indian, that are available up there because a lot of people want to use them. So for the follow-on station or adding to ISS, we want a lot more of those capabilities. I think one thing I wanted to clarify is that we are not heading in the direction of real-time PCB only, that we're only going to recruit PCB. That's only a little part. So we're absolutely going to still have automated, we're going to have these kinds of hardware. That is absolutely still part of the picture. That was kind of, it's filling a niche, but I don't know that that's going to be something in the future. There was concern expressed that obviously the astronauts have different capabilities, and there's a lot of variability in well. So one of the suggestions was the CCP4 list, which I my brain, it's the Craigslist of international researchers, but perhaps there's a list that we can advertise, and I think it's a European list. I don't know how we do that with an RFP, but are there lists that we're missing that we could advertise to get more researchers to come forward? We talked about OMM, and that's a capability that's going to go away, but maybe we'll talk that offline, and maybe we can help bring it down and get it kind of refurbished and upgraded to launch it back up again.
All right. So our action item coming out of this meeting is to take your advice. And first will be to put everything online for everybody to access. We'll put together a report, but we'll be going back out to people for feedback to make sure that we're capturing what everybody was providing to us. I think that there's a number of people that, or at least we're hoping a number of people are going to continue collaborations out of this. I'm going to be pressing some people on different items coming out of this. We'd like you to take the RFP announcement. We've updated our trifolds. And then as far as for today, I think the rest of the time we can be in here for till 4:30, whenever. Yeah. And Eddie's kind enough to organize the tour. So the rest of the afternoon is yours, and we really appreciate all coming out here. And I think one of the things that we hear the most is that we need to do this more often. So maybe we'll just follow ACA around in the future. It makes the most sense. And I think if we could probably do it actually at the conference, because we had limitations because it's in Toronto this year, but next year I think it's in Kentucky. So we'll look to with the organizers, see if we can have a workshop dedicated there. maybe get some additional users. So that, we're done on our side. So thank you.